We are still into sketching the graph of our simple circular functions. And in particular, we are looking into the effect of the period on the appearance of the graph of our function. So let us go back to sketching your simple function y is equal to sine of x. We already did this last time and we already showed it. Let us do it one more time. So again, the period of y is equal to sine of x is equal to 2 pi divided by 1. 1 is the coefficient of x. That's b. Okay, so the period in general is computed by 2 pi divided by b. So in this case, our period is equal to 2 pi. Well, what that means is the horizontal distance covered by one sine curve is 2 pi. So that means from 0 to 2 pi, we shall have one sine curve. Now, in sketching the graph of this function, you don't have to produce so many points. All you have to do is look for the x-intercepts. That is the first step to do. Look for the x-intercepts. And between those x-intercepts, you will have your point where your function will achieve its maximum value. In this case, it's 1. And the minimum value is -1. So we know that the x-intercept of y is equal to sine of x are 0, pi, and 2 pi. Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. And you know also that sine of pi over 2 is equal to 1. Sine of -3 pi over 2. No, sine of 3 pi over 2 is -1. And so what you will do next is you will just trace a smooth curve through those points. Okay, so that is one sine curve. And then after that, you can just repeat the curve. From y is equal to sine of x, let us go to y is equal to sine of 2x. So again, what is the period of y is equal to sine of 2x? Okay, so b is equal to 2. So our period is equal to 2 pi over 2. It's equal to pi. The horizontal distance covered by your one sine curve is pi. So that means from 0 to pi, we shall have one sine curve. So again, just like what I told you, you don't have to produce so many points to help you sketch the graph of this function. All you have to do is pay attention to these points. What are the x-intercepts? And where or what values of x will give you the maximum value of sine, which is 1, and the minimum value of your sine function, which is -1. Let us look first for the x-intercepts. So what you do is you equate this. Sine of 2x is equal to 0. When is sine of 2x equal to 0? It is equal to 0 when 2x, okay, so when this thing is equal to 0, pi, and 2 pi. Okay, because when this thing is 0, sine of 0 is 0. Sine of pi is 0, and sine of 2 pi is also 0. So what then is the value of x? And so right away, you can go to your rectangular coordinate system and mark those numbers. 0, pi over 2, and this one is pi. Those are the x-intercepts. You know what happens between 0 and pi over 2, okay? So that is in the first quadrant. Between 0 and pi over 2, your function or your sine function is positive. So it will achieve its maximum value between 0 and pi over 2. And you know where it's going to happen. It will happen at the midpoint of 0 and pi over 2. So that is pi over 4. So when x is pi over 4, the value of your sine function is 1. So you can already trace a smooth curve here, okay? And then, you know what happens between pi over 2 and pi. your curve will descend below the horizontal axis. And between pi over 2 and pi, which is 3 pi over 4, your function will achieve its minimum, which is equal to -1. So you can just now trace a smooth curve through those points. So look at that, look at that. What we have here is one sine curve in the interval 0 to pi. And then what you can do next is you can just repeat the curve. Before we go to sketching the graph of y is equal to cosine of 0.25 times x, let us trace the graph for y is equal to cosine of x. So we know that the x-intercepts of this function will occur when x is equal to pi over 2, 3 pi over 2, 5 pi over 2. And by the way, the period of y is equal to cosine of x, okay, x is, again, 2 pi. So from 0 to 2 pi, we expect to see one cosine curve. What is cosine of 0? It's 1. Okay, so these are our x-intercepts. Okay, so right away, you can now draw a smooth curve. What is cosine of pi? It's -1. And then that is an x-intercept. You just connect it. What is cosine of 2 pi? It's again equal to 1. So that is one curve or one cosine curve for your function y is equal to cosine of x. Okay, so let us now proceed with y is equal to cosine of 0.25 times x. Okay, so 0.25, I hope that you can recognize it to be equal to 1/4. And so our period now is equal to 2 pi divided by b. b is 1/4. So our period is 8 pi. So what that means is from 0 to 8 pi, we shall have one cosine curve. So what do we do next? Well, what we do next is, just like what I told you, solve for this. What are the x-intercepts of this function in the interval 0 to 8 pi? When is this equal to 0? Okay, so this is equal to 0 when this thing is equal to pi over 2 and to 3 pi over 2. And then solving for x. Now, why is that so? Why is that so? Again, 0.25x is equal to pi over 2 or 3 pi over 2. This is the same as 1/4 times x. Okay, so solving for x, we multiply by 4. It becomes, okay, 4 divided by 2 is 2. So it becomes 2 pi. And then 4 times this, okay, we cancel 2. So it becomes 2 times 3, which is 6 pi. So 2 pi and 6 pi, those are the x-intercepts. So when x is 0, so let's begin here. When x is 0, look at this. Cosine of 0.25 times 0 is cosine of 0. Cosine of 0 is 1. Now, right away, you can already draw a smooth curve going to your, smooth curve going to your x-intercept. This is an x-intercept. You know what will happen next. Your curve will descend below the horizontal axis. It will become equal to -1. Okay, the value of your function will become equal to -1 when x is equal to the midpoint of your x-intercept. So here at 4 pi, okay, 4 pi. At 4 pi, your function is equal to -1. And then just trace it. When x is 8 pi, look at that. When x is equal to 8 pi, 1/4 times 8 is 2 pi. 1/4 times 8 is 2. So it becomes cosine of 2 pi. And you know that cosine of 2 pi is equal to 1. So look at that. In the interval 0 to 8 pi, we have this one long cosine curve.